All right, now we've covered the constant rule and the power rule. Now we're going to cover the constant product rule, which builds on top of the constant rule that we've already covered. So let's say we have a situation where we want to take the derivative in a situation where there's a constant and a variable. Well, conveniently, we can simply move that constant in front of the whole expression and then calculate the derivative of y with respect to x separately, and then work with that derivative that we separately calculated and multiply it by the constant. As an example with numbers, let's start off with the same function that we derived on the preceding slide, the power rule slide. So we had y is equal to x to the power of 4, and we determined that the derivative of y with respect to x is then 4x cubed. So that's just the power rule. Now let's combine what we determined here with the power rule with the constant product rule. So let's say we want to calculate the derivative of 2y. Well, we know from the constant product rule that we can take that 2 and move it in front of the derivative, and then we can simply calculate the derivative of y with respect to x. Well, we already calculated that over here for this particular function, so we can substitute in dy dx with 4x cubed. And now that we've done that, we can use the constant 2, which we moved out of the way initially, and multiply that by 4 to give us our final answer of 8x cubed. Now that we've seen all the details of the constant product rule in action, we can eliminate a few steps and make it a lot easier. So if we have, say, this constant 2 in front of this variable x to the power of 4, when we want to calculate the derivative of y with respect to x, we can simply treat them separately. So we can calculate dy with respect to x of x to the power of 4. So we've already seen this a couple of times. X to the power of 4 differentiated is 4x cubed. That's using the power rule. So now that we have that, we can simply multiply it by the 2 that we left off to the side, and that leaves us with 8x cubed. So exactly the same result as we were doing on the preceding slide, but just saving a lot of extra steps. The key thing here is to just remember that if we have a constant in front, we don't need to worry about it. Just set it aside for a moment, calculate the derivative with the other available aspects of the term, and then bring the constant back in after we've calculated the derivative.